Okay, we're starting chapter 3 today, and it is doing real numbers and absolute values. So if you haven't noticed how the book has been progressing, in chapter 1, all your answers were integers. So that meant your answers were like -5 and 12 and 0 and 1 and pretty numbers. Chapter 2 were fractions, what we called rational. And there were any fractions, 1/2, 1 1/5. Why is my thing not writing? 2/3. So now we're bumping it up to chapter 3. And chapter 3 says real numbers. Well, real numbers are the highest form of number that you know. And that is anything you can think of. It looks like any twig. But anyway, anything. So that could be integers, it could be rationals, it can be our new word, which isn't really new, irrational. So that means in this chapter, you're going to start seeing some weird numbers, like pi is irrational, and the square root of 3 is irrational because you can't take the square root of 3. It goes on forever and ever. And you should know this. This should all be review. So, speaking of review, the chapter starts off with our friend, the absolute value. So we take a little time to review absolute value. And remember, when we solve it, we have to look on both sides of the absolute value. We have to look on the positive side and the negative side. So the positive side is x minus 5 is greater than or equal to 3, x is greater than or equal to 8. And the negative side would be negative x plus 5 is greater than or equal to 3. Negative x is greater than or equal to negative 2. X is less than or equal to 2. And if we graphed this, we'd go here at 8, and we'd color the circle in because it tells me x can equal 8. And then we come over here, we said x can equal 2, so we'll color 2 in. And then we cheated off of here to see that it is a disjunction. So our graph went this way. And then it went this way. Which makes sense because this says x is greater than 8. And here I am greater than 8. And this says x is less than 2. So here I am less than 2. Now, back in chapter 2, we had that really weird 2.8 lesson. And we started looking at our graph as if we took out our graphing calculator. Now remember, I did this. I looked at this as two separate graphs. I looked at this as the graph. Y is the absolute value of x minus 5. And in that picture, over here, this is what the graph of the absolute value of x minus 5 looks like. Then I took the other side, and I looked at that as y equals 3. And here is the line y equals 3. Now the question was asking me, what x values make the red graph be greater than or equal to the blue graph. All right, when I look over here, my x values, here is my red graph, and an x value, what's this x value right here? Well, that's the x value 2, is where the red and blue graph equal each other. 1, the red graph is above the blue graph. 0, the red graph is above the blue graph, so any x values this way. And then right here, this is the number 8. So any x value above 8 makes the red graph be above the blue graph. And of course, all the numbers in between. That's why we shade them in, because it represents those fractions, irrational numbers, integers, any of the real numbers. Okay, hopefully by now my smart people have looked at this problem and answered it. That's right. Casey's laughing at you going, I know the answer to this. I'm going to walk away and get myself a little snack and come back when the video's caught up with her. If I take the time to solve this right here, okay, let's see, 3x minus 3, I'll pull the 4 over to the other side. I'm going to divide by 3 to isolate the absolute value. Does anybody see it yet? The answer is every number in the world. And this is our shortcut for writing every number in the world. This symbol means all reals. Because won't absolute value always be greater than or equal to a negative? Well, it's always greater than a negative. How would I do that on a number line? Oh, that's like you being back in your childhood days. You would color in every single number on the number line if you were graphing it. And that's what your number line would look like, a big black mess. Now, once again, just to show you what it would look like on a graphing calculator, I would say y equals 3, absolute value of 3x minus 3 plus 4. And then I would do a second graph of y equals negative 6. And let's see what it looks like. There we have it. If you don't know what you're quite looking at, well, let's trace it. Here's the red graph right here. Here's the blue graph down here. This is the graph where y equals negative 6. So it was asking me, where is the red graph greater than or equal to the blue graph? Everywhere the red graph is above the blue graph. All reals. Yay. Okay. By now we can blow through this, and this should be algebraically, okay, 5x minus a half is greater than 3 halves. 5x is greater than 4 halves. 5x is greater than 2. X is greater than 2/5. All right, here's the negative. Negative 5x plus a half is greater than 3 halves. 5x is greater than 2 over 2, which is really 1. So x is, whoops, let's bring my negative down so I don't lose it. X is less than negative 1/5. Now, look at my number line here. My number line here is in wholes. So I'm just going to change it. I'm going to change it to fifths. Now this is why we don't label every number when we do a number line. Because now I have to go and label each one of these as fifths. But you get the idea. So here's 2/5, open circle. Here's negative 1/5, open circle. And we can cheat, and we know that this is a disjunction. So we can shade this way, and we can shade this way. And we have covered every irrational, rational, integer, everything. All right, let's just take a quick look at the graph. There it is. Let's get rid of that. And once again, I think you know it by now. This is the red graph because it's on the right. And here's my red graph. Just like that. And then here is my blue graph. And the question asked me, where's the red graph above the blue graph? Well, these points where they cross out right here, you just found out. Those were the points negative 1/5 and 2/5. And see, from here on in, the red graph is above the blue graph. So anything greater than 2/5 gets the red graph above the blue graph, and anything less than negative 1/5 gets the red graph above the blue graph. Last one real quick. Casey, tell me, what's the answer here? You can do it. That's right. Once again, it's all reals. Did I just do that one twice? No. Whoop. Okay. Well, if I solve this, let's see, 3x minus 3 is greater than or equal to negative 6. 3x minus 3 is greater than or equal to negative 2 because I'm going to divide by 3 here. And where's my absolute value greater than or equal to negative 2? Everywhere. How about if I change this and did this? Oops. So if I solve that, 3 less than or equal to negative 6. So where's 3x minus 3 less than or equal to negative 2? Where would absolute values be less than or equal to negative 2? Nowhere. Bye. Have a good weekend.